My name is Shawn Bodily. My company is Airlock Home Energy. I specialize in pretty much anything with the energy code, new construction, retro, anything like that. But our focus is new construction and on helping builders, meet these codes. They're kind of difficult to navigate, and at times they're can be somewhat onerous. So, a little bit about me. I got into this actually kind of roundabout. I started doing duct sealing. We have the AeroSeal duct sealing machine, and we started doing that for HVAC guys that were having trouble hitting energy star codes for duct leakage. And from there, I got certified to do the blower door and duct blaster testing, and then I started getting calls to test for codes. So from there, I had a couple of builders that a particular project that had it was a 30-unit apartment complex or condo complex, and they failed every single unit on the blower door test. So we went to try to figure out what was going on. I looked at insulators and everybody else to try to figure out what exactly needs to be done, and most insulators, most builders didn't really have a good solution for how to get these down. Multifamily is a really difficult code to hit, especially on the blower door side. So we started kind of experimenting, and the trouble with this code, especially blower door code, is you've got to do the work at rough and you can't test till final, right? So in how you're building townhomes, especially, there is a system, right? Every couple of weeks you're starting a new foundation, and then everything's in line and you're constantly rolling through those buildings. So by the time you can test, you're usually 2 buildings deep before you can see results for what that test was. So it was pretty difficult to kind of figure out, and that's a challenge, because now really the only thing you can do is to do everything you possibly can on that first building, see where it tests, and then kind of pull back to where it makes sense. Luckily, single family is a lot easier to hit, but if you're in the multifamily market, it can be tough. I've had builders building basically the same plan as someone else. A lot of these townhomes and condos, their plans are not substantially different, not really structurally different, and one can test way under code or pretty close to code, and another one is just blown it out of the water at like 12 air changes or something, right? So they can be all over the place, and it's really tricky to figure out why. So we started doing a lot of the work. I do testing still, and still, guys are all over the place. So hopefully this can give you an idea of where to start, some of the things we look at when we're trying to get these to pass, and some of the places you can improve on, and also give you a good understanding of what the energy code is asking for, and now the fresh air code, because that's starting to interact with the energy efficiency code, and there can be some conflict there, and some perceived conflict. It's not really conflict, but I'm trying to give a better understanding of what that is. And of course, this thing doesn't want to work again. There we go. Okay. So we'll cover the Utah amended energy code requirements and how it's changed from last year to this year. Differences between single family and multifamily as far as the code's concerned, fresh air requirements and how they interact with the energy code, problem areas for both duct sealing and strategies for fixing those, and strategies for air sealing, and differences between single family and multifamily. So to start, the Utah amended energy code duct leakage requirement. The previous code, this is 2020, is really 2019 and 2020 were under this code. Previous it was even different. So what Utah has done is you have the 2015 energy efficiency code, and Utah has amended sections of that, but they've kind of tiered it in so that I think it was 2017, it started at one level, and slowly every 2 years they've dropped the code a little bit to make it a little tighter, just to give guys an opportunity to sort of gradually roll into the code requirements. Problem there is that there'll be a new IECC, and maybe those codes change, and then we start this whole process over again. But hopefully these things don't get pushed too far or further. So the previous code had a duct leakage test, or duct blaster test commonly called, had to be performed on every system that had 25% of all ducts outside the building envelope, or the HVAC system was outside the building envelope. So a garage, a attic, a crawl space, that's outside envelope. If someone says you need a duct blaster and your ducts are inside the main floor, you know, between the basement and the main floor, your basement is a livable basement, that is inside conditioned space, and the air handler's downstairs, that's inside conditioned space. You shouldn't need a test. The new for, and then the leakage allowance previous to this code was 7 CFM per 100 square feet. So for 21, they've dropped that percentage to 20%, and then dropped the leakage allowance to 6 CFM per 100 square feet. Now, it doesn't seem like a big change, but we're sort of on the marginal, you know, increases, and this has been fairly significant in terms of, you know, passing versus not passing. When we test stuff, it seems that if you're below 1,200 square feet, you start to run into trouble. It starts to get a lot trickier to pass this code. If you're 1,000 square foot upstairs and you've got a attic system, you know, that's obviously 600 or 60 CFM that you're allowed. That's not a whole lot. That's not just ducts either. That's ducts plus air handler. It all has to be tested together. I have seen personally air handlers that have leaked 90 CFM installed, even masticed. You know, not crazy. This was a test we did with an HVAC company. We hauled a big, you know, national furnace brand out here to show them, hey, we install this, we sealed up how you say, and I'm still seeing 90 CFM just between supply plenum and return drop, right? And that includes filter, furnace, and coil, and just above there is where we stopped it. We blocked the whole thing off, tested it, and we had 90 CFM just there, okay? So it is rare that you're gonna see an air handler that's leaking below, you know, 30 or 40 CFM. That's what that sealed up pretty well. They caulked or masticed all the penetrations on that air handler and done a pretty good job. So when you've only got 30 CFM in all the ducts, that includes your boot to drywall connections if you're testing at final. That includes every elbow in there. I mean, that's not a lot of leakage to deal with. And that's the typical case for this is air handler in the attic with flex lines. Flex lines don't leak a lot. If you're running into fully sheet metal systems that have a jumper into the attic, those sheet metal systems leak like crazy compared to flex. Those jumper systems are where I'm seeing the most trouble getting them passed. Even though you add the square footage, the added square footage doesn't usually come out to help you out as much as the extra leakage you're adding to that. So this is the code. We'll get into some more of the issues and what we're looking at later, but this is what the code has changed. So now, if your air handler's outside conditioned space or the 20% of the duct work, and that's measured by length, is outside conditioned space, you have to have a duct blaster test. So watch that in your builds. Sometimes you can adjust that a little bit so that you know, if you know you're going to have a test on this system, maybe you do something a little bit different, either get below that threshold or consider a second system. Obviously, jumpers don't perform as well as a second dedicated system, but obviously there's a huge cost difference there. So just consider that and understand what is going to cause some of these or trigger some of these tests. The envelope sealing, so this is what the blower door tests, the whole leakage for the entire house. Previous code is required on all residential units. Energy code allowed up to 3.5 air changes per hour, and multifamily allowed 5 air changes per hour. So an air change is simply when we set up our test at negative 50 pascals, which is just the pressure, we get a leakage number. That leakage number is just divided over the volume of the house, and that gives you an air change. So It's simply how often the air in the house is being exchanged at the pressure we're at.
What is that in PSI, Pascal?
I think a Pascal is like 1/400th of a PSI. I'm not exactly sure. It's not a very high pressure. The 21 code is still required on all residential units. An energy code allows up to 3 air changes per hour. So you have to be below 3 air changes per hour now for single family. Multifamily is allowed 5 air changes. Now, the national code does not have a different requirement for multifamily. That is a Utah amended section. Okay, so if Utah's always going to be under some pressure to be in line with the national code. If they do move that code back to the 3, that's going to be problematic, because with a lot of work, you can get a multifamily down to 5, but a lot of multifamilies are not even at the 5. And I can go through some of the stuff we do on multifamily, but we're pegging, low 4s, maybe mid 4s if it's a small unit, high 4s, barely making that code, and we're doing a whole lot of work to get there. So if that code ever does go back to 3, there's going to be some problems. Let's see, envelope tightness implications with fresh air code. So the previous code, like we talked about, allowed up to 3.5 air changes of leakage. Fresh air code requires mechanical ventilation if the blower door result is under 3 air changes. So you had a window, right, where there's a sweet spot between 3 air changes, 3.5 air changes, where if you hit that, you don't have to do extra mechanical ventilation, but you also pass the energy code. So you were golden, right? New for 21, energy code, you have to be below 3. Fresh air code, if you're below 3, now you have to do mechanical ventilation. So, mechanical ventilation is, in effect, required on every single family home. Mechanical ventilation is not, it's not just adding leakage. People get the, and it's understandable because you're saying, well, you're too tight. Yeah, but you're adding mechanical ventilation, we're not talking about just opening a window. That is a huge amount of leakage. We're talking about a very small amount of leakage, but directed, right? So it's a little bit of forced air exchange just to allow moisture and bad air and avenue to escape. So if you are too tight, even in this area, you will have moisture problems. There have been builders here that have been building energy efficiency stuff for a while, and before they started addressing this, they were consistently having some moisture problems. So the mechanical ventilation is typically the solutions for that are typically a continuous flow exhaust fan or an ERV or an HRV. The exhaust fan is the typical option builders are going for, especially spec guys or production builders or multifamily. Absolutely, exhaust fan is the way to go. Multifamily, of course, you're not usually below the 3, so it's not really something that most guys are having to worry about. The exhaust fan is typically, when I recommend putting one in, I usually recommend a bathroom that's not occupied all the time. So not an ensuite with the master. That's just going to be annoying, of course, having that run on all the time, because that exhaust fan does have to be continuously run. There is an option for an intermittent, but it has to average at whatever the chart specifies at that CFM. And the problem is you cannot have that switched on or off. It has to automatically come on and off to average that air exchange. An ERV or HRV is a better option. It provides a direct avenue outside and exchanges air through the air handler system or the HVAC system to the return air to exchange that air, and it goes through much of the energy is recaptured because it's going through a heat exchanger or whatnot to recapture some of that energy, so you're not just sucking in outside air. Of course, that's the critique of the exhaust fan option, because you're sucking out bad air, but it is sucking in unconditioned air just wherever there's leakage in the home. So, that's the drawback, but obviously you're typically about $2,500 for an ERV HRV option, whereas the exhaust fan, you're an extra $100, $200. This chart is a simplified chart that Utah's adopted in order to make it easy to know what exactly you've got to have for that fan rating. I've never had an inspector say, hey, I want that fan tested for what the leakage is or what the actual rate is. If you put a fan that's 100 CFM or rated 100 CFM into a home that's super tight, it's not going to put out 100 CFM. But typically, if that fan's rated 100 CFM, it doesn't matter. The inspector sees 100 CFM on it, and that's all he wants, then he's fine. So I wouldn't worry about it at this point, about having those tested. But, you know, obviously, this chart is based off of number of bedrooms and square footage, and, you know, it's pretty simple to figure out what you need. Most homes, if you can source a 120 CFM fan that's continuously run, that's going to handle almost all the homes you're doing, unless you're doing big custom stuff. So, you know, typically I recommend just if you've got to create a standard for your home, especially if you're a production guy and don't really want to figure out per home what we need, 120 CFM is going to take care of most of the homes. Duct sealing. Yeah.
The exhaust fan in the bathroom option,
Yeah.
does that have to roof penetrate? Can it just go?
No,
to
just
the attic
outside.
space?
No, okay, it does have to go to the outside.
Okay,
Yeah.
it has to go to the outside.
Yes.
Okay.
Yeah. I have recently had a little pushback from a building inspector that wanted a direct vent out from the HVAC out to the outside of the house. That is a recommended option in the code, but it's not required. The requirement is only that you have the fan or some kind of exchange of air at whatever rate it says. So after the back and forth, it was decided that we were doing it properly, of course. And so, but sometimes you will get a little bit of pushback because this is part of the code that is kind of ambiguous and nuanced a little bit, right? So there's some understanding that's probably not there on all levels. So you know, work with your guys. I'm always happy to take a phone call or whatever. You know, most of what I do is actually walking builders through, you know, what exactly do we need to do and why. And I've talked to building officials on many occasions walking through this, and obviously that's a delicate conversation because they're the building official. But of course, the code does not require extra steps like that. So regardless, you know, the bathroom fan does satisfy the code. Problem areas with duct sealing. So where that code's at now, like I said, if you're dropping below about 1,200 square feet on that system, it's starting to get pretty tough to pass. The biggest areas I'm seeing that guys are struggling on or doing that are really causing a whole lot of leakage are panning returns, any wall chase returns or joist cavity returns. Those just leak like crazy. No matter how much work you do, they leak a lot more than sheet metal will. So if you know that system's going to be tested, do not put panning in it. I know it's difficult, especially now everybody wants this open floor plan, so it's difficult to get returns places because you got limited walls, you know, versus older homes. But panning will kill you. Jumpers, like I talked about, if you have a basement system, you're jumping up into the attic, that attic section of that system is going to trigger that test, and all that sheet metal from the basement system plus the jumper, that's a ton of sheet metal to try to seal. Those systems struggle a lot. Garage systems, this is kind of one of those gray areas where if you've got it in the garage, you can insulate it and put an exterior door on it and seal it off and call it inside the envelope. Depending on the location, I've seen inspectors say, no, that's outside the envelope. Now you've got to have a test. And I don't know, that can go either way. And that's one of those areas that's not very clearly defined as what's in conditioned space and what's not. So avoid putting them in the garage if you can, because, you know, depending on where you're building, you may have an inspector say, I'm calling that outside conditioned space, I want you to test that. Small systems, like I said, Energy Star actually has a floor. Utah code does not have a floor. So what I mean by that is Energy Star, if you never have to have a single family system below 80, because they've written that into the code. Utah code doesn't have that sort of thing. So I've had systems, attic systems on 600 square feet. Well, that system can only have 36 CFM of leakage. Very, very difficult to pass at that point. Furnace, drops, and plenums, those are areas that need to be hit very well with by the HVAC contractor. The furnace leaks like crazy. In fact, most of the systems now, that furnace probably accounts for at least half the leakage in the ductwork. Boots to drywall or subfloor connections, those really need to be hit well, especially if you're testing at final. How the testing is typically done is you tape over the register, pressurize the system, and then test it. The problem is with that register in, if that's not sealed well to the boot, you're also adding an additional leakage in the duct. At every connection, you're adding leakage at the boot to drywall connection. Some of those I've seen leak 10 per connection, like right off the bat, you can't pass. So those need to be done very well if you're going to test at final. I would suggest testing it rough if you can. The code doesn't specify which you've got to test at. If you've got Energy Star, the requirements change between rough and final. I always think it's better to test it rough because you got options. If you test it final and you're failing, not a lot you can do. You're calling me to do the AeroSeal stuff, and when you haven't planned on it, it's going to cost you, more than you wanted it to. Methods for sealing. So obviously tape mastic, every joint, every seam, every clip, it doesn't matter. Make sure every single junction that's not pure sheet metal is sealed. Special attention to the furnace and trunk lines for flex systems. Those trunks, those connections, they still leak a ton. And then the furnace can leak a lot on its own, so pay attention there. Like I said, we do the AeroSeal system. If you're not familiar with that, we pressurize the whole system, blow an aerosol in, and that automatically seals up all the holes. So it works like Fix-A-Flat. The advantage is I don't need to find the leakage. My guys set it up and play games on their phone for an hour while it seals itself, right? So it's very effective, but I do not seal the furnace. Obviously, if I block off the furnace, because if I sealed the furnace, you would have no cooling. I would ruin, all the orifices it would be a mess, right? So furnace still needs to be sealed. We have had systems that I've got down to like teens, if I combine the two sides, being 15 or 20 CFM, and still we fail because the furnace is leaking too much. So that's how tight this code is. So it's really got to be something that you have a conversation with your HVAC guy and really get down to the nuts and bolts of whose responsibility is where and really work together on it because, as you can imagine at final, we do hundreds of seals a year, especially Energy Star stuff. We're in Daybreak all the time doing the Energy Star stuff. And you get to final and you're failing and everybody wants to point fingers, but, there's 100 things that happen between rough and final, and who knows what happened, right? So just understand that this is a difficult code, and everybody needs to be on it. And it's a conversation you also need to have with your trades. Say, look, I know that this isn't necessarily your job, but if something breaks, if something happens, either fix it or let someone know, because you know how that gets. So no one lets anybody know something's broke, and drywall goes up, and now everybody's throwing their hands in the air and pointing fingers at each other. Everybody needs to be involved in this stuff. Spray foam insulation, especially in attic systems, I've seen some guys just cover the whole trunk out to the flex hoses in spray foam. That seals it and it insulates it. I think that's a great thing to do, but you're probably $300-400 to do that. Yeah, so it's not the cheapest, and you still got to worry about other connections. But that is a solution I've seen. Air sealing envelope, single family. Are you guys all generals in here? You're HVAC? General? General. Okay. So for the air sealing stuff, we're going to talk about single family and multifamily separately because there is a pretty substantial difference in where like kind of the natural leakage is with where the current codes are and where the requirements are. So again, single family, just to rehash, you have to be below 3 air changes. For single family, it's not that hard to get to 3 air changes. If that's a typical floor plan, full foundation wall, basement, sufficient square footage, it's not too bad. Basically, you're looking at penetrations, and then, kind of think of the envelope ceiling as, in most cases, drywall is your air barrier, right? So think of any penetration into the drywall as, where you need to stop, right, to block that leakage. You can do this other ways. There is zip system and other stuff. Zip system is great, and it's good because it's not a sacrificial layer like drywall is, so you don't have penetrations going in and out all the time. However, I've seen some successful zip systems, but it is a lot of work to make that zip system actually meet these codes. I've seen a lot of these guys that think the zip system is going to take care of it and just have not paid attention to every little penetration through that zip system and not been as successful as they thought they were going to be. So electrical, plumbing, HVAC, all those penetrations into the envelope need to be sealed, need to be addressed. In addition, usually insulators take care of that. Most insulators can do that okay, but going a little bit beyond that to get below 3, you may consider double sill underneath the mud sill or underneath exterior walls, just depending on the situation. Sill on the face of the top plate or spray foam insulation on the rim joist. That's a big one. That's probably the first one I recommend when guys go in and they're having trouble with their single family. A lot of times they still have an unfinished basement, so hitting the sill or the rim joist with spray foam and just filling in that gap between all the way down the foundation wall up to the subfloor. That is probably the quickest, best bang for your buck, especially at that stage of the house. Because realistically, once you're at final, you're not getting this down a whole lot. That building I mentioned in Park City at the very beginning, we were at final. They failed all of them. The super called the inspector and immediately told them we failed. So it was a nightmare to go through. We went through, put gaskets on behind all the electrical plating and all that stuff, and we dropped it to like 6.5 from like 7.5, and we did a ton of work. So at final, not a lot you can do. But the spray foam insulation on the rim joist is one. If your basement's unfinished. Sealed can lights or reduce the number of can lights and speakers. If you're in a custom home, they got tons of can lights or tons of speakers, you can tent them. Speakers, you got to tent them. None of the speakers out there that I'm aware of are that airtight. So you can tent those. You can sill or the spray foam insulate just the lid and just do a layer 1.5 inches or so of the ceiling. That's a really effective way to do this. It takes care of all those penetrations into the attic and all that. Of course, spray foam insulation, you're about $1 a board foot, so it's not cheap. And then special attention to bonus rooms. So in my home, we have a bonus room, and the bonus room extends over the garage and then over the back patio. So it's a really big bonus room. Bonus rooms leak like crazy. The problem with the bonus room is the subfloor goes down on the bottom cord of the truss, right? So you don't have a bottom plate on the wall. We ended up cutting blocking in between each stud and making a bottom plate so that we could put our gasket on the bottom plate and have a positive seal for our drywall to seal to. We also got this special tape and taped up all the seams on the subfloor. And we did pretty well. My house is just below 2 air changes, or like 1.8 air changes or something like that. So we did my house pretty well, and since then we've kind of been able to improve on that. So most houses, when we do them, we can get them down to 1.5, sometimes near a little closer to 1. But there's a lot of work that goes into that. When we're doing single family or we're doing any of it, we're doing a gasket on the drywall. We're sealing up all the outlet boxes. We're sealing up all the penetrations, not only vertical stuff, but a lot of the stuff in the studs too. So there's a lot of work that goes into this to get these down. Luckily, if you're just trying to get to the code, the 3 air changes, it's not a ton of work. Grabbing a couple of these things, start with the sill on the face of the top plate. That's a quick one. It's going to cost you like $200 to have your insulator do it or whoever. And that might get you from 3.5 down to 3. Most guys right now are in that sweet spot, that 3 to 3.5. And we've only started testing a couple that were 2021 codes, so we haven't really had to be below 3 yet. But it shouldn't take you a ton for single family. Yeah.
What about radon systems?
As in the leakage they add?
Yeah. How do you deal with ventilation that's required there?
So,
Usually that's after the fact, so nobody knows.
yeah.
You've got your CO, I don't know.
Right. So I don't know. We've tried to seal, and this is kind of a tangent, but we've tried to seal in-slab ductwork with the AeroSeal system for radon. My AeroSeal fan box puts out, I can't remember what it is. It's like 2,000 CFM. Okay, so it's a pretty big fan. When I've tried to do those systems, it registers as 0 leakage. Like not a little bit. Any leakage that I show is leakage from our plugs, right? Like it is essentially 0. And that's with the 2,000 square or CFM fan. I have no idea how these radon fans that are 100 CFM are doing a lot.
They're putting, in new construction, you put your gravel bed down, then you put your radon piping in that gravel bed, then you have your vapor barrier. And so in essence, radon is outside the building envelope. And so it's not pulling air out of it. Now, I don't know
On the
about,
new systems.
Yeah, that's on new construction. I don't
Right.
know about
Existing,
existing.
they typically,
Drill down in
drill it down in the concrete. And I think I've never
still
installed one,
outside
but
the building envelope.
I think for the most part, effectively, it's not in or out. And like I was saying, I can't register a ton of leakage with my big fan. So the little fan they've got, I don't think, even if you had a little bit of leakage in and out, we're talking about enough to affect anything. When I'm doing a duct leakage test, like, my home were 1.8 air changes, and I think the CFM for that was like 2,100, 2,000 CFM. So the fan that is rated at 100 CFM in a really tight environment, maybe putting out 40 CFM, like it's a blip, Any questions on single family before I move to the multifamily? Okay. Let's see. Multifamily. So multifamily, like we said, is at 5 right now. When that first changed to 5, nobody was passing that. Most of the multifamily that I was testing at the time was somewhere like 6 to 10 or 7 to 10. Okay, so we ended up, like I said, with that one building, just testing a ton of different stuff, and kind of we've got a pretty good combo right now of what we do on multifamily. But I have some stuff I do. And then there's some stuff that we also have framers do, like we do extra sill underneath the mud sill. We actually do sill underneath the bottom plate on most of the exterior walls on multifamily. And then I do a drywall gasket, and I seal up the boxes, and I seal up the penetrations. And we actually do that as opposed to their insulator on most of the time. To get those to pass. If you're doing multifamily, you got to do everything with the single family. In addition to, you got to do something about the outlet boxes, because again, think of the drywall as your air barrier. If I'm sealing up the penetration in the ceiling for the Romex that's going through the top plate, So that hole's sealed, but I'm coming down, I've still got a hole in the wall. Even I got to seal up the back of those outlet boxes. And then I even suggest that you have painters or whoever makes sense, caulk the connection between the electrical box and the drywall to further seal off that whole thing. Because once you've done that, now you've got no leakage from the drywall all the way up through the top plate. So you've completely sealed that off. And then you also got to consider, you know, your bottom plate. You got to do something about the bottom plate. The tough thing about bottom plates is we'll do a drywall gasket. We kind of do that drywall gasket everywhere. And but that bottom plate, you know, you see drywall put them up, and half the time they're not even touching the bottom plate, right? Like it's on the top of so sometimes you miss that. Unfortunately, this is something where you kind of have to do everything the best you can and realize there's going to be some parts that are missed, right? But that also goes back to all your trades kind of being involved in conversation and knowing, hey, you know, this is what we're trying to accomplish. This is where the codes that are at now. So I've got to pay a little more attention to my part of this to make sure that, you know, I'm making connection with that gasket or that sill or whatever it is, or I'm not ripping down the sill when I'm lifting my drywall to the wall, you know. It's like I said, it's just a big, everybody's got to be involved in it, and it's a learning curve for sure. The partition or the firewall between units on multifamily is really tough. You've got the zinc or whatever they're made of those little clips, right? And so those are designed to melt and then collapse the drywall into the wall and create an air block, right? But in order for those to work, they have to be offset from the studs by an inch or an inch and a half or whatever it is, right? So you've got this gap that's got to be there for fire code. But then that gap right there is making it really difficult to pass energy code. The other problem you got is if I've got 200 CFM of leakage on this unit and 200 CFM of leakage on this unit, when I test this, and if I've got leakage on this unit and leakage on unit B, and there's 200 CFM of leakage through the partition wall, it's counted on both units. And there's no way to isolate that. You could isolate it with, you know, a blower door on both of these units and on the third one, but that's not practical to do in most cases, and the code actually doesn't have any allocate or allotment for doing it that way. So those are some of the reasons why multifamily gets tough. The other reason is, you know, most multifamily is slab on grade. So you don't have the square footage of the basement to help you out with the square footage. Because basements help a lot because they don't leak a lot, but you get the square footage. So the other, like I said, caulk outlets to the drywall box, or outlet boxes to the drywall. Sill under exterior walls. Seal ductwork if outside condition. If that ductwork is outside conditioned space, any leakage in that ductwork is also counting on your blower door. And, you know, if you've got penetrations, especially those gaps, like I said, the boot to drywall connection, those are huge for leakage to the outside, and all that's getting counted on your blower door. And then spray foam attic floor or top plates of walls from attic. So that's one thing. If you do have a good attic space in the home, like I said, you can either spray foam the lid, or you can just go along and spray foam just the top plate when it makes connection to the drywall. Of course, you know, everybody shies away from spray foam because it is so expensive, but it is a pretty good way to handle this. If you spray foam walls, I mean, that seals up that wall really well, but again, you know, spray foam's probably, realistically, spray foaming stuff everywhere is the most costly way to handle this, or most of the time the ductwork too. Sealing ductwork, spray foam is a pretty expensive way to do it. All right, so that kind of concludes this. We kind of burned through that pretty fast. Any questions you guys have?
So the easiest floor plans to do are going to be single family home Rambler.
Yeah.
Because you've got a lot more square footage in the basement.
Yeah.
And if you had like detached garage doesn't hurt you at all, but an attached garage can hurt you if you have ducts somewhere.
Yeah. So, like you said, probably the easiest single family plan to seal for the blower door anyway is going to be a Rambler. And like you said, because the square footage in the basement's higher. But you start adding walkouts and stuff like that, you know, or stick framing, especially if that walkout's stick framed. You know, that's basically, you know, a second level. It doesn't matter, right? Garages, I couldn't say for sure. I'm sure if you didn't have the garage, it'd be probably a little bit better, because I think people pay less attention to that demising wall between the garage and the actual home. But every home here, for the most part, has an attached garage, so I don't have any kind of sample for having just a detached, really. But yeah, the single family Rambler is probably the easiest to pass. The funny thing is, it's a difficult code for small square footage stuff, especially multifamily condos. Those are the most difficult. But then, as you get bigger square footage, this gets easier, to a point where you start getting like the big Park City stuff, Promontory, where they've got codes that you can't have a straight wall that's more than 24 foot or whatever, right? So you end up with 40, 90-degree walls and points all over this house, and then they get really difficult, because again, you get to that point and now you're typically slab on grade again, or part of the house is slab on grade or with a crawl space. And so I've had as much trouble on like these 8,000 square foot big stuff in Promontory as I have on the townhomes. Because again, that big stuff in Promontory, those big houses, they're still at the 3 air changes, right? So getting those down is sometimes as hard as the multifamily.
I don't see a whole lot of people doing this blower door test and air change.
Yeah, I've never heard of this.
The blower doors?
I've never
Blower
heard
doors,
of
I
like
have, but I
any
just
gaskets on the
Yeah.
penetrations of I've never heard.
Yeah,
of
and
We're gonna start to look at this more and more and more.
so over the last few years, they've sort of gradually, cities have adopted this. It's been code since I think 2013 is when it was adopted, but they've sort of, it was 5 air changes or something was what it was back
So
then.
it was easier.
It was easier. So they've slowly tightened up the codes, and at the same time, cities have adopted this. So I still get calls from guys that say, I've never had to do a blower door, I don't even know what it is. And I'm incredulous, because I'm like, how many homes do you build that you've never had to do a blower door? But all of them, yeah, it depends on where you're at, because
In the Park City world, and
well, Park City's been on top of this forever.
but I don't see it very often.
Really?
It's really interesting.
So part of that is where the codes have been. We're just now, like I said, I don't think I've had a single home yet with all the delays that we've had that has been on a 21 permit. So everybody's still at the 3.5 air changes. So once you get to the 3 air changes, that's kind of where this stuff is getting a little trickier on the single family. The multifamily guys have had to deal with this for a little while.
Because just being the HVAC, we just seal it up really well.
Yeah.
We spray foam all of the stuff that's in the attics and that, and maybe because we do that, we don't see it as.
Yeah, and
We're not called on it.
right, and and we do, like I said, we do 400 aeroseal jobs a year on different homes, and so, but most of that is Energy Star. Probably 20% is not. Just because a lot of the HVAC guys, if they know it's going to be sealed, it's going to be in an attic, they'll just call me and I'll seal it, and then we'll take care of it. You know what I mean? They don't got to think about it again. And then they take care of it at rough. They've got someone else to point the finger at if we got a problem at final. But on the Energy Star, you have to seal both systems. So that's where like a lot of that's coming in, because you can still with a lot of work. It sounds like you guys are spray foaming though in the attic, and that's not a cheap way to go. But the AeroSeal is $950 at rough, right? Yeah. Yeah. Hit that too, yeah, and so it is somewhat absorbed, right, by other trades. The Energy Star stuff, if you've got that basement system, it's still got to be sealed, and it's still got to pass Energy Star code, and those codes are the same, for the most part, very close. So when you have a sheet metal system, like those systems are difficult, especially if it's all sheet metal. And for a while, you still had guys trying to pan stuff, and still, you still have to do some panning. You can't get away from it. I mean, you know the problem as well as anybody. I got a pipe, and it's got what, a half the volume as the joist cavity would. So
You got everything running through.
Right.
Electrical running through and they leak like.
well, yeah, and no one pays attention, you know, and honestly, people don't put the amount of mastic that is required to actually seal those. It'll seal, and you'll get till final, and it'll be fine. It's supposed to be a nickel thick, right? I've never seen a system nickel thick, you know.
We got
So-
it all done at once, so we do a better job at it.
Yeah, yeah. I mean, and that's kind of where a lot of our business comes from. Is the guys get a couple of jobs that they end up 2 weeks dealing with, and they're just like, we're done with this. You just take care of it at rough, you know.
Cool.
But back to your point, I think part of the reason why you haven't seen a lot of that done is because the code has not quite been there yet to require it. And so, you know, guys are kind of in this sweet spot, can do a little bit to get down below 3.5. Still in single family, we don't have to do our whole package. We'll do the whole package if the homeowner is concerned about energy efficiency and wants the home as efficient as possible. But just to pass the code, I will do some customers, I will just do gasket and do a quick job of the gasket, and it's cheap for them and they just take care of it, and we're well below 3. It's usually only the guys on the single family that want to be down below 2 and have, you know, the extra comfort and the energy efficiency and whatever that we're really doing a lot on. Like I said, the multifamily guys are probably the guys that are really struggling with this stuff. And I know those are kind of all over the place with how they've dealt with it. And we've figured that how we're dealing with it is the most cost-effective way when you consider everything else. But yeah, in terms of air sealing, I think last year we did only 20 or 30 single family, and we did 200 multifamily on the air sealing. So it's still the bulk of the blower door stuff in terms of like major problems is the multifamily still. Okay, well that kind of concludes this. My information's up on the board. If you're in person, I've got my info there. If you do have any questions, or I'm happy to just take a phone call and answer any questions you got. Like I said, a lot of my day is just chatting with builders and telling them how I'd approach some of these problems and how to deal with it. But yeah, let me know if you have any questions. Thanks for attending the webinar.